Welcome to PGSMaths. In this video I'm going to be looking at scattergraphs, what they're used for, how we make them, and then how they are used. A scattergraph is used to compare two sets of numerical data to see if there is a relationship between the two sets of numbers. In this example I'm going to be looking at students' test results to see if there's a relationship between the results they get for maths and the results they get for science. Each student will be represented as a small cross plotted on a set of x and y axes. The scale along the bottom will start at 0, but it doesn't have to. Generally, I would recommend you start at 0 because it allows us to predict future results, which is something we'll look at later in the video. I've scaled each of my axes so I can fit up to 100 on both axes because we're looking at percentages. The first student is represented by these coordinates. Their maths result was 87% and their science result was 68%. So if you find both of these values on each axis, you can plot a small cross to show where that student is. So this cross here is our first student, and we'll repeat this for the remaining 5 students, going across 52 for the maths result, up to 41 for the science result, plotting a point as a little cross, and repeating until all the students have been plotted on the scattergraph. Now we can see immediately that there is some sort of pattern here. The results are making quite a nice line, and that's what we're looking for when designing a scattergraph. What you should do once you finish plotting your points, if you can see a relationship between these points, is to draw a line that goes through them. Now I'm going to make an assumption here that if you get 0 on maths, you're going to get 0 on science. This might not always be the case, but a line that represents most of these points can be drawn through all of those points. This is called a line of best fit. It doesn't have to go through all the points, but should be always drawn on a scattergraph. If there is no pattern, if you cannot see where the line would go, then maybe there is no relationship. But in this example we can quite clearly see that all of the points do make this nice line. What this graph now shows us is that the higher the maths score goes, the higher the science score seems to go. And this is what's called positive correlation. Positive correlation is used to describe the relationship where one number has a positive effect on the other. There are examples of this that include the further you travel, the more it will cost. So if you plotted travel versus cost on a graph, you would see this increasing positive correlation. So how can we use this? Well, once we have a line of best fit, we can make estimates as to what missing data might be. If we got 40% in maths but didn't know what the science result was, we can use this graph to predict this missing value. To do this, we're going to need to draw some extra lines on our graph. So maths was 40%. So I'm going to find 40% on the maths scale and draw a line from the axes that goes up until it touches the line of best fit. From there, we now move across until it hits the other axes. What this lets us do is to predict what this point might be. It has to be an estimate because we know not all the points lie on this line, but it gives us a pretty good idea. In this case, it would give us a science result of about 32 or 33%. It's very important that we show these lines so that we can identify where this number has come from. In a similar way, if we know that science is 75%, we find 75% on our science axis, draw a line across this time until it hits the line of best fit, and then go down to the maths axis to show that the student in this case should have approximately 80 or 90%. The accuracy of your graph and the positioning of your line of best fits would have an effect on this result, but generally you'll find it'll be very, very close to this. There are other kinds of correlation that can be found, and here are the two other most common forms. The first one is when the values seem to create this downwards relationship. Again, drawing a line of best fit shows us that the slope is going down. And this is called a negative correlation, showing that distance has a negative relationship on remaining fuel. So the further you travel, the less fuel you have. On this graph over here, it's very difficult to see if there is a relationship. Maybe there's not enough points. If we plotted more points, a relationship or correlation might show up. But at the moment, we cannot see any kind of pattern. Therefore, this is known as having no correlation. So here's our challenge of the day. I borrowed this graph online and figured we could use it to come up with a slight problem. A bank worker is earning £50,000 a year. He thinks he's been with the bank for 30 years. But what mistake could he have made? Have a think and leave your answers in the comment section below. Do remember to follow us on Facebook and Twitter, and send me any questions that you might have or requests for future videos.